स्टार्ट कीजिए.
Today we are going to study the important part of physics, that is sound. That is for 11th science. Sound, in that specifically we will see, that is wave motion. What is wave motion? First of all, wave motion, number of types of wave motion or motions we have studied. That is translation motion, linear motion, rectilinear motion, projectile motion. Number of types of motions we will come across during 11th standard. But this is something new. Before defining the wave motion, we will come to first one point, that is called as oscillatory motion. Oscillatory motion is that motion which repeats after equal interval of time. That type of motion is called as an oscillatory motion. Means every equal interval of time, the motion repeated. This can also be called as a periodic motion also. Therefore, oscillatory motion have some characteristic, that is first characteristic, that is period T. Second characteristics, the frequency. And third characteristics, that is amplitude. Means period is the time required to complete one oscillation. Frequency is the number of oscillations performed during unit time. That unit time may be second, minute, hour or anything. And amplitude is the maximum displacement done during the course of oscillation. These are the three main characteristics of the oscillatory motion. Now let us proceed to define what is wave motion. Typically, in short, the wave motion is the oscillatory disturbance produced in a medium. Therefore, wave motion is simply oscillatory motion, oscillatory disturbance produced in the medium. We come across number of examples. First, suppose in a steel pond, if you throw small stone, it gives number of concentric circles. These concentric circles are like this. Suppose at the center, if you throw small stone, it gives one circle and second circle, third circle. Likewise, these circles are go on propagating with increasing radius. I think everybody has enjoyed at the childhood this. Second example, if you simply stick a rope, if you string in one hand, at another end you just clamp it. If this is a string, hold it in your hand, just give a small jerk. If it is loose, then it behaves like this. This type of motion is also one of the basic examples of wave. Therefore, here, if you observe, all the concentric circles are forming, and these concentric circles are go on increasing till the end of the pond. And here also, these waves go till the end where it is fixed up. Can you say that these particles are moving? If anything else, suppose a small paper is floating on water. If you critically observe, that paper moves up and down only, that's all. It does not get carried on the surface. Here also, if any part, thread is slightly colored, suppose, if you give the wave, that colored part of the thread remains there only. Means from this we can conclude wave motion does not transfer particles. It transfers only the energy. It is very critical to remember. This wave motion will have these type of again characteristics. For every wave there will be a period. The time required to go from here to here, from same phase of position, or from here to here, same phase. That time is called as a period. Frequency, suppose this wave travel here in 1 second. Suppose from here to here it is traveling in 1 second. If you go on measuring 1, 2, 3, 4, 5, there are 5 waves. Therefore 5 cycles per second we can say. And this new unit of frequency is hertz, that is 5 hertz like this. These are the characteristics of. There are 2 different types of waves. If you observe these 2 waves, these are having the same thing. But first category, types of waves. Types of waves. Here, the particle which is kept up, just I told you, piece of a paper, and here a thread, current part of the thread. It vibrates up and down. This piece of paper also vibrates up and down. But the wave travels in this direction, from here to here. Here also the wave travels in this direction. Such type of wave is called a transverse wave. Second type means the wave is propagating in this direction and the particles are vibrating in this direction. Secondly, longitudinal wave. Longitudinal waves. These waves here, the wave travels in this direction, the particles are vibrating in the same direction. For example, compression and rarefaction. When sound travels, traveling of sound is come under this category. Means there are 2 types of waves, longitudinal wave, transverse wave and